electromagnetic theory. I think you have already started this paper, electromagnetic theory, and you have studied the Coulomb's law for point charges, and then you have already studied the Coulomb's law. Then what you have studied next? Next you have seen the charge distribution in one dimension, two dimension, and three dimension. This charge distribution may be uniform or non-uniform. These all are the things you have studied already. And here we are coming to Coulomb's law for continuous charges. Already you have studied the continuous charges. Here we are going to apply the Coulomb's law for continuous charges. So depending upon the charge distribution and a point charge, is a point charge q, and this is a charge distribution. Here this is a point charge q, and this is a charge distribution. So depending upon the point charge and charge distribution, we are taking the two cases: symmetric charge distribution and unsymmetric charge distribution. Here only you can see that with respect to this q, the charge distribution is symmetric. There are two sides. Okay, so what we are going to do is, in this condition, we are going to take two elements, two charge elements. This is dq1 charge element. Here also we are taking another charge element, dq. So in symmetric charge distribution cases, we are taking two charge elements. Two charge elements we are taking. And second case, we are considering half integrals only. Take half integral only. We'll see how we will take all these things. If this is from minus L by 2 to L by 2, this length is from minus L by 2 to L by 2, and this is 0. Here we are taking only half limit, 0 to L by 2 limit only we are considering. And in cases of unsymmetric charge distribution, we are taking only one charge element. Only one charge element we are taking. That is, here we can take one charge element, dq. Total charge may be q. Here also total charge of this charge charge distribution may be q, and this is a charge element. Here also this is a charge element. One charge element we are taking, and in this case we are taking full integral. We are considering full integral, that is from 0 to, if it is L, 0 to L, that we are considering here. This is the first thing you have to remember: symmetric charge distribution and asymmetric charge distribution. Coming to an example, this is a charge q. We have already told that, and this is a total charge q, a charge distribution. This is a symmetric case. This is a symmetric case that we have considered. So what we told, this is a charge element. This can be called as dq. And this is another charge element. This can be also represented as dq. So first you consider, you want to find a force between this charge distribution and this charge q. So first we consider this dq, this charge element dq, and finding a force between this charge element dq and this charge q. So how we will take the charge? This is a charge q, this is another charge. Both are positive charges, so there will be a repulsion between these two charges. So we are taking a force here, means we can simply like this. This will be a force. This will be the force. It is a repulsive force. So away from the charge, repulsive force. And this is also a positive charge element. So here also we will feel a repulsive force only. So repulsive force. This is a force F. You can represent as dF because it is due to a charge element dq, no? So this is a dF and this is also a dF. If we are considering this angle as theta, and this is also theta, and we are putting a normal here. If this is theta, this angle will be theta, and if this is theta, this angle will be theta. Opposite angles in all these cases. And if we have a force along this direction, you know how to resolve this vector into two elements. How will resolve? There will be a horizontal component and there will be a vertical component. So if this angle is theta, this angle will also be equal to theta. So this is df, then this component will be, this is the component which is adjacent. So this is cos component, this is sine component, df sine theta, and this is df cos theta. Is it? Then for this force vector also, there is a vertical component and there is a horizontal component. Here also this angle will be equal to theta and this component will be df sine theta and this component will be df cos theta. So considering these four forces, df sine theta, df cos theta, df cos theta, here also df sine theta. This both df are same because this charge element, here we have taken d theta, here also we have taken d theta. Both angles theta are same. So df sine theta and this df sine theta, these two are equal in magnitude but opposite in direction. So they will cancel each other. Then what will be the total force? Total force, total force due to the charge elements, total force due to the charge elements dq, dq's, this dq and this dq. So I will just represent it as f only. So df only will be equal to df, will be equal to this df cos theta plus this df cos theta. So total will be equal to 2 df cos theta, 2 df cos theta. So what will be the total f? F will be equal to integral 2 df cos theta. From where to where we have to integrate? We can take only half limit. This is a symmetric charge distribution, so we need to take only half limit. So if it is minus L by 2 and L by 2, we need to take only from 0 to L by 2 limit only. So this limit will be 0 to L by 2. This is the total force appearing in this case. And coming to unsymmetric case, this is the first case we have seen that, and this is the second case, that is, it is an unsymmetric case. So this is a charge q, it is having a total charge q, it's distributed in this manner. So this is unsymmetric. What we can do here, we can consider only one charge element dq. This is a charge element dq, and what will be the force acting on q? This is also a repulsive force because dq is positive charge and q is also positive charge. So there will be a repulsive force in this direction. So this is a force along this direction, a repulsive force from here to this straight line. Consider it as a straight line. Okay. Okay. So this is a force acting here, df. Due to the charge element dq, there is a charge df. Here also we can consider as two components. If this angle is theta, here also we can consider it as two components. If this angle is theta, if this angle is theta, just a minute. Okay. If this angle is theta, this angle will be also equal to theta. This angle will be also equal to theta. So this component will be df cos theta and this component will be df sin theta. Here there is no other force to be cancel each other. So we are having two components here along y direction and along x direction. How we will write along x direction? Dfx will be equal to, this is the x direction. This direction is called x direction. So df sin theta. So what will be the total force? Fx will be equal to integral df sin theta. Integral from where to where? 0 to L. Total limit you have to take here. 0 to L df sin theta. Then what will be the force acting on y direction? Dfy will be equal to df cos theta. So what will be Fy? It is equal to integral df cos theta. From where to where? 0 to L. So this is the case. And coming to problems, we'll see the problems later. In that cases, we will find what will be cos theta and we will apply the limits. Numerically, we will do that. Okay. So coming to next case. It's a third case that we are considering. It's a third case. Just tell me this is, just think this is symmetric or unsymmetric with respect to the charge Q. It is symmetric, is it? This is symmetric because by seeing the charge distribution from this charge Q, you can see a symmetric manner here. So this is also a symmetric charge distribution, but it is not linear. That is the difference. It is not linear. So here what we are going to do here also we are taking two components. This is the first component dq. Here also we are taking another component that is also dq. And what is the force between these two? It will be repulsive only. So it will act along this direction, that is df. And from here also there is a repulsive force acting on this direction, that is also df. And just take, if this angle is theta, if this angle is theta, the opposite angle will be equal to theta. And if this is also theta, this opposite angle will be equal to theta. Okay. So what is the force here? df. This is the force df. And this force can be resolved into two components. This is a vertical component and this is a horizontal component. So this angle is theta, means this angle will be also theta. So it is df cos theta and this is df sin theta. Is it clear? And here also, if this angle is theta, here also we are resolving into two components. This angle will be equal to theta and this component will be df cos theta and this component will be df sin theta. So considering these four cases, four forces, df cos theta and df cos theta, these both are same in magnitude but opposite in direction. So we'll cancel these two forces. They will cancel each other. Then what will be the total force? Total force due to these two charge elements, total force due to this dq and this dq on q will be equal to, you can represent it as df only. Df will be equal to df sin theta plus df sin theta, means 2 df sin theta. So the total force due to the charge distribution, we have to find the total force due to the charge distribution force. F is equal to integral 2 df sin theta. Then how will be the limits here? Can we take it as minus L by 2 to L by 2 or 0 to L like that? No, it is not a linearly distributed. So we can tell it as in terms of angle. From 0 to, what will be the angle here? This is 0, then 0 to pi is the total limit. So do we need to take the total limit here? No. This is symmetric charge distribution. So we need to take only half the limit. So what will be the limit? 0 to pi by 2 is the limit here. Okay. Then coming to a fourth case, this is a non-symmetric charge distribution. Here consider this is a, here this is a charge q is here. So with respect to this q, there is a charge distribution here, total charge q. So is it symmetric? No, it is not symmetric. It is not a symmetric charge distribution. Only one part is here. If one more part is from here to here, one more part is there, it will be symmetric. But here only one part is there and unsymmetric charge distribution. So what we will do? We take only one charge element. This is a charge element dq. So what will be the force here? This is a positive charge. This is a positive charge. There is a repulsive force. So we can represent the repulsive force like this, away from the charge. This is a repulsive force here, df. Then if this angle is theta, while resolving this vector, force vector into two components, if this angle is theta, then just consider, if we are plotting like this, this angle will be also theta, opposite angle. This angle is theta means if we are taking a line here, this angle will be theta means this angle will be theta, isn't it? Then this component will be df cos theta and this component will be df sin theta. So we have got two components, df cos theta and df sin theta. So how we write here? dfx, this is the x direction, no? So dfx will be equal to df sin theta. So fx will be equal to integral df sin theta. And here dfy will be equal to, this is the y component. Oh, sorry. I just mistakenly here. This is the y component. This is the y component. This is y along this direction. This is y component. dfy is equal to df sin theta. This is fy, and here I have to write fx. This is the fx component. So df cos theta, which means fx will be equal to integral df cos theta. So what will be the integral limit here from this point to this point? No, that is from 0 to pi by 2. This angle 0 and this is angle pi by 2 from here. Here we have to take half limit. No, we have to take full limit. We cannot take half limit here. We have to take full limit because it is asymmetric charge distribution. So from 0 to pi by 2. Here it is full limits, 0 to pi by 2. 0 to pi by 2. Okay. So we are going to do some problems based on this concept. Before going to the problems, you have to remember two formulae based on uniform charge distribution. Uniform charge distribution. You know what is uniform charge distribution? The charge distribution is uniform everywhere. That is, the charge, linear charge density will be lambda equal to dq by dx. It will be equal to q by L, like this. If it is distributed like this, a total charge q is distributed along a line segment of length L, then the linear charge density lambda equal to dq by dx will be equal to q by L. This is uniform charge distribution. In case of uniform charge distribution, you have to remember two formulae mainly, that is integral x divided by x square plus a square whole raised to 3 by 2 will be equal to minus 1 divided by x square plus a square whole raised to 1 by 2. Of course, dx is here. And another formula, integral dx divided by x square plus a square whole raised to 3 by 2 will be equal to x divided by a square into x square plus a square whole raised to 1 by 2. These two formula you have to remember. Here one x is here, so in answer there is no x, and here there is no x, here one x is here. You just remember these two things. Okay, I just told for remembering. Okay, so coming to a problem, consider a thin rod of length L. Here we have thin rod of length L and charge q. The total charge is q. Then a point charge is placed at a distance d from one end. From one end at a distance d, there is a point charge q as shown in figure. Find the force between them. So we have to find a force between these two things, this charge distribution and this q. So you know how to find this. There is a charge distribution which is not symmetric with respect to this charge q. So this is an asymmetric charge distribution. So how we'll take a point element? We have to consider only one element. This is an element, charge element dq. This is only one charge element we are considering here. We don't know at what distance from q we are considering this charge element. So here we are taking it as x. From this charge element, there is the distance x to this charge element dq. From this point charge, there is a distance d to this charge element dq. So how we will find the force? Force will be equal to df, force due to this dq, and q will be equal to df, which is equal to 1 by 4 pi epsilon 0 q1 q2 by r square, or 1 by 4 pi epsilon 0 can be represented simply as k into q. First charge is q, then second charge is dq into dq divided by what is the distance between x square. This is the force. So we don't need to find this only, we need to find total charge, total force F. We need total force F only, not dF. So F will be equal to integral dF, which is equal to integral kq dq divided by x square. Okay, so it's equal to, we need to change, this is a variable x, so we need to change this dq into dx. So how we'll change? You just consider how we have defined this linear charge, this density lambda. It is equal to dq by dx, which is also equal to q by l in case of linear uh, linear charge, in case of uniform charge distribution. So you just consider this part, lambda equal to dq by dx. So dq will be equal to lambda dx. So substituting back, integral k q into instead of dq, what we can write, lambda dx divided by x square, which is equal to k, q and lambda are constants here. K, q, lambda are constants from dx, integral dx x square. Here I will write it once more. F is equal to k, q, lambda into integral dx by x square. From where to where we have to take the limit? X is changing. Here the variable is x. X is changing from where to where? X is from this point the charge is starting. This charge distribution is starting. So from D to up to where we have to take? Up to this n we have to take. So D to D plus L. This total length is D plus L. So the limit is from D to D plus L. D is the starting point of this rod, and D plus L is the end point of this rod. So this is the expression. So which will be equal to k, q, lambda, and what is integral of minus 1 by x square? Integral of 1 by x square is minus 1 by x. Limit is from D to D plus L. So it is equal to k, q, lambda into substituting these values. So there is a minus sign, so I am going to substitute this d first. So 1 by d minus 1 by d plus L. You have to give upper limits minus lower limit, as there is a minus sign, and it just changed like this, which is equal to k, q, lambda, then cross multiplying d plus L minus d equal to L divided by d into d plus L, d into d plus L. So which is equal to k, q, lambda. What is lambda here? Q by L. Totally lambda will be equal to q by L. So k, q by L into 1 L is here, and d into d plus L is here. So cancelling this L and this L, what will be the result? K, q, capital Q divided by t into d plus L. This is a force between this rod and the point charge q. Is it clear? I think it is clear. Then coming to another problem. So coming to the second problem, find the force at q. Find the force at q. So how to find the force at q? This is a condition that we are going to analyze. So there is a charge distribution, and there is a charge q at a distance d from the center of this charge distribution. So it is a symmetric case. And how we will solve this? We have to consider two charge elements, first one here and similarly a second one here. So we don't know at which distance we are considering this. So just we are assuming we are considering this element at a distance x from the center. Here also at a distance x from the center we are considering. So this distance is x and this distance is also x. Okay. Then we know the force acting on Q due to this element dq will be what force? It will be a repulsive force in this direction. We already told that this will be equal to df in this direction. And what will be this df? Will be equal to df will be equal to, just consider df will be equal to, just put the Coulomb's law, k into what is q1? This is q1. Q1 is q into what is q2? dq is q2. So first charge into second charge divided by the distance between, square of the distance between them. So what is this distance? This distance is x and this distance is d. So considering it as a right angle triangle, this angle is theta and this is 90 degree, then this will be hypotenuse. So what will be this distance? Square root of x square plus d square. So square of the distance, square of this quantity will be x square plus d square. This is the force df due to the charge dq. And as we told already, we have to take it as two components here. If you are taking an angle here theta, this will be also theta. This is opposite angles theta. If this angle is theta, this will be theta. So this will be df cos theta component and this will be df sin theta component. Similarly, by taking this dq, this charge element dq, there is another repulsive force here. A similar repulsive force will be in this direction also. That is also equal to df. It is also similar. This distance is d and this is x. So this distance will be d square plus x square or x square plus d square. So this force will be equal to k. First charge is q and the second charge here dq divided by the distance square. Distance will be d square plus x square, or same manner x square plus d square. Its square will be simply x square plus d square only. No need of root here, just x square plus d square. Here also you can take two components, this component and this is another component. If this is also theta, if this is theta, this angle will be theta and this angle will be theta. So this will be df cos theta component and this will be df sin theta component. Okay, so we know this is df sin theta, this is df sin theta, opposite, equal and opposite, so this will cancel each other. What will be the total force? The force due to both charge elements, due to the both charge elements, the force will be equal to, we will simply represent it as df, which will be equal to df cos theta plus df cos theta. The sin theta components will cancel each other. Here is a cos theta component and here is another cos theta component, so it will be equal to 2 df cos theta, so which is equal to 2 into df. What is df? We have found the df here or here, both the same. So what is df? K q dq divided by x square plus d square. Then cos theta is here. What is cos theta? If this angle is theta, how to find cos theta? Cos theta will be equal to adjacent side by hypotenuse. Okay, adjacent side means this distance. This distance is d. Cos theta will be equal to d, adjacent side d divided by hypotenuse. What is hypotenuse? Root of d square plus x square or x square plus d square. It will be equal to root of x square plus d square. So we can write it as 2 into k q, this d is here, d, then dq divided by x square plus d square whole raised to 3 by 2. 1 is here, 1 by 2 here, so 3 by 2. So this is the total force here. We'll just write it as, again we will rearrange it as 2k q, then d into dq can be written as, dq can be changed as, what is dq or what is linear charge density lambda? Lambda will be equal to dq by dx, which can be also written as q divided by L. We'll see this part only now, that is dq will be equal to lambda dx. So here dq can be changed as lambda dx divided by x square plus d square whole raised to 3 by 2. This is the force df, force due to both charge elements. We need to find the total force due to total this charge distribution and q, the force between this whole charge distribution and q. So what we will do, we need to integrate from where to where. This is symmetric charge distribution, we have to integrate half limits only. So from 0 to L by 2 only we need to integrate. So I will write this force one. So I will write the df once more here. Df is equal to 2k q d lambda dx divided by x square plus d square whole raised to 3 by 2. Don't consider it as d lambda, okay? D is the distance and lambda is the linear charge density. Okay, then we need to find the total force due to the entire charge distribution, isn't it? We need to find the total force due to the entire charge distribution. That will be, F will be equal to integral df, which is equal to integral 2k q d lambda dx divided by x square plus d square whole raised to 3 by 2. We can take the constants outside, so 2k q d and lambda can be taken outside. Integral dx divided by x square plus d square whole raised to 3 by 2. And we know it is a symmetric charge distribution, we need to find only half limit, so 0 to L by 2 only the limit, 0 to L by 2, and which will be equal to 2k q d lambda into, what is the result of this integration? Just before you have seen a standard integration, integral dx divided by x square plus a square whole raised to 3 by 2. Here instead of a there is d, that is only difference. So just see that formula and we can write this equation as the result as, what is the result? It will be x divided by, this is the result of the integration, d square into x square plus d square whole raised to 1 by 2. From where to where? 0 to L by 2. So substituting the upper limit and lower limit, there is no lower limit is 0, so that term will be 0. So substituting the upper limit only, f is equal to 2k q d lambda into, simply a bracket, L by 2, that is the limit, L by 2 divided by d square into L by 2 square plus d square whole raised to 1 by 2, which will be equal to 2k q d lambda into L divided by 2d square into this L square divided by 4 plus d square. By taking the cross multiplication, taking LCM, that we can rewrite it as L square into 1 will be L square plus 2 square will be 4. 4 into d square will be 4d square divided by 4 into 1 by 2, which is equal to 2k q d lambda into L divided by this 4, under root 4 will be equal to 2, so this can be cancelled, 2 and 2 can be cancelled. The remaining will be L square plus 4d square whole raised to 1 by 2. This can be rewritten as 2k q d Then lambda can be written as lambda. How we define this lambda? Lambda equal to dq by dx, which is equal to q by L, no? So we have already taken this case. Here we can take lambda equal to q by L. That case we can take here. Let's consider here. Lambda can be written as q by L. Lambda can be written as q by L into L divided by L square plus 4d square whole raised to 1 by 2. So L and L can be cancelled, which will be equal to 2k q d q, capital Q, divided by L square plus 4d square whole raised to 1 by 2. So uh, okay. Here there's one more small mistake is here. D square. Here one d square is here. Here also one d square is here. Here also one d square is here. I have forget the d square. Here also d square is here. Okay, so this d and this d square can be cancelled. So what will be the final answer? 2k q, capital Q, divided by d into L square plus 4d square whole raised to 1 by 2. This is the final answer. Okay, this is the final answer. 2kq, capital Q, divided by d into L square plus 4d square whole raised to 1 by 2. This is the final answer. So coming to the next problem, find f at q. This is the problem. So this is the q and this is a charge distribution of total charge q, and it is having a length L. Here we are considering this a unsymmetric charge distribution with respect to this q. It is an unsymmetric charge distribution. So we are considering a charge element dq here at a distance x from the end. From here at a distance x, we are considered a charge element dq, and this charge element makes a repulsive force on q such that it can be represented as like this. This is the force df. This is the force df due to the charge element dq. So df will be equal to, what is df? K into q, then second charge is dq divided by the distance square. What is the distance? The distance between q and df will be this distance. What will be this distance? This distance is x and this is d. Then this will be the hypotenuse of this triangle. Then it will be equal to x square plus d square. So the distance square will be x square plus d square. Then we can resolve this force into two components. This is the vertical component and this is the horizontal component. So if this angle is theta, this angle will be also theta. If you are plotting like this this angle will be theta, and if this angle is theta, this angle will be also equal to theta, and this side of theta will be cos theta component. So this vector can be represented as df cos theta, and this component can be represented as df sin theta. Okay, so yes, we can just take first we can consider this component. This component means this is y component and this is x component. Let's consider the x component first. We can represent it as dfx. X component of df can be represented as dfx will be equal to df sin theta, which is equal to, what is df? This is df k q into dq divided by x square plus d square into sin theta. What is sin theta? If this is theta, from this triangle, sin theta will be equal to opposite side x divided by the hypotenuse, that is x divided by square root of x square plus d square, which will be equal to k q dq into x divided by x square plus d square whole raised to 3 by 2. Also, it can also be written as k q. Then what is this dq? What is this dq? That is an expression. We can write the linear charge density lambda will be equal to dq by dx, which is equal to total charge q divided by total length L, as it is a uniform charge distribution. So we will consider this side first. Lambda equal to dq by dx, or dq can be written as lambda dx. Okay, so here we are having a dq and all the other terms are in terms of x, variable is x. So we are changing this dq in terms of dx, that is lambda dx into x divided by x square plus d square whole raised to 3 by 2. Okay, so we are having a dfx here. So here we can consider, we can find out fx. Fx means the x component of the force acting on q due to the total charge distribution, capital Q. So fx will be equal to integral dfx. It will be equal to integral k q lambda x dx divided by x square plus d square whole raised to 3 by 2. This is expression which will be equal to, again the constants can be taken outside, k q lambda integral kq lambda into integral x dx divided by x square plus d square all raised to 3 by 2. Okay, so this is the component, x component of the force, which is v equal to k q lambda into, this is the integral from 0 to L is the limits. So this integral is a standard integration and the value will be equal to, as you know, the value will be equal to minus 1 divided by x square plus d square whole raised to 1 by 2. This is the integral value. So the limits will be equal from 0 to L. So what we will do, which is equal to k q lambda into that, as there is a negative sign, we can put the lower limit first. That is, when we are putting x is equal to 0, this will be equal to 1 divided by d square whole raised to 1 by 2, that is d, minus, and we are putting this L into here, 1 divided by L square plus d square whole raised to 1 by 2. So this is the x component of the total force, and we need to find the y component. So what is dfy? Dfy is the sine component of, dfy is the sorry, not sine component, the cos component of the force, that is df cos theta. I think you are remembering this figure. This is the charge distribution, and here the q is here, this distance is d, and at a distance x we have found a charge element dq. So this distance is x square plus d square, and this angle is theta. Okay, is it clear? So here we are taking this cos component. That's the cos component or vertical component we are taking, df cos theta, which is equal to, I already found the value of df, that is equal to k q dq divided by x square plus d square. This is the value of df. And cos theta, what will be cos theta here? As this is theta, cos theta will be equal to adjacent side by hypotenuse, that is equal to d divided by square root of x square plus d square. So which is equal to k q, dq can be changed in terms of x. First we are taking this d, and this dq will be equal to lambda dx divided by x square plus d square whole raised to 3 by 2. Here one term is there and root is here, so 3 by 2. Okay, so what will be the total force? Total force along y component, y direction will be Fy, which is equal to integral dFy from 0 to L, which is equal to, we are taking the constants outside, k q d lambda into integral dx divided by x square plus d square whole raised to 3 by 2. This is integration from 0 to L. So as this is also a standard integration, k q d into lambda into that integral value will be equal to x divided by d square into x square plus d square whole raised to 1 by 2 from 0 to L. Substituting the values, first we can substitute this L. While substituting x equal to 0, the total term will be 0. So we need to substitute only L. So k q d lambda into x is equal to L. L divided by d square into L square plus d square whole raised to 1 by 2. So here this d and this d will get cancelled, which is equal to k q into, and lambda will be equal to capital Q by capital L, lambda equal to capital Q by L into L divided by d into L square plus d square whole raised, sorry, d square whole raised to 1 by 2. Here L will also get cancelled, which is equal to k q capital Q divided by d into L square plus d square whole raised to 1 by 2. So this is the x component of, sorry, y component of the total force. I think it is clear.